conversion of NFA to DFA using lazy evaluation method. So a problem is given, convert the given NFA to DFA using lazy evaluation method. We know that if it is NFA, from one state on one input we can make multiple transitions. Say for example, Q0 on 0 can go to Q0 as well as Q1. We will have to convert this to equivalent DFA. We will see the method for this. So step 1 is identify the start state of the DFA. NFA is given to us, we have to convert it to the DFA. For that, we will have to identify the start state of the DFA. So for this, we will see the start state of NFA. The same thing will become the start state of the new DFA. Since Q0 is the start state of NFA, Q0 within the set notation will be the start state of the DFA. And every time we find a new state, we are going to add it to QD. QD will be the states of the DFA. Okay. So QD equals Q0. Step 2, identify the input alphabets of DFA. Here there is no change. The input alphabet of NFA will be the input alphabets of the new DFA. So sigma equals 0, 1 itself. Now identify the step 3 is identify the transitions delta D of the DFA. So start from the start state Q0 and find the transitions as shown below. Here what we do, we will have the start state and we know the input symbols. Every time we will start with the start state, we will apply the input symbols. We will get a new state. If that new state is already in QD, we won't do anything. If it is not in QD, we will add it to QD. And for that new state, we will apply the inputs. If in this case it is 0 and 1, so we will apply the inputs. We will make the transition. After making the transition, we will get two states, right? If those two states are already existing in QD, we won't do anything. If those two states are not existing in QD, we will add it to QD. So we will repeat the same step till we reach a place where no new states are found. Okay. So once all the states have been, transitions have been applied to all the states, we will reach a point where there are no new states. At that time we stop. Then we look at the final state of the NFA. Okay. So the final state of NFA, then we look at the final state of the NFA. In this case it is Q1. Wherever we have Q1, all those states become the final states of the new DFA. Okay. So we will make a transition table as and when we do the new transitions, we will go on adding the entries to the transition table. So once we are done with all the states, we draw the transition diagram. So that is the procedure to convert NFA to DFA. Now look at the diagram. So Q0, this is the transition table for this diagram. We have three states Q0, Q1, Q2. So Q0, Q1, Q2 are the three states. Q0 is the start state, mark it with an arrow. Q1 is the final state, mark it with a star. Okay. Now the input symbols are 0 and 1. So 0 and 1 are the input symbols. Now we will have to prepare that transition table. Q0 on 0 goes to Q0, Q0 on 0 goes to Q1. So Q0 on 0 goes to Q0, Q1 because it is going to two states. Now Q0 on 1 goes to Q1. So Q0 on 1 goes to Q1. Now let us consider this state Q1. Q1 on 0 goes to Q2. Q1 on 0 goes to Q2. Q1 on 1 goes to Q2. So, Q1 on 1 goes to Q2. Now, Q2 on 0, there is no transition. So, we will mark it with a 5. Q2 on 1 goes to Q2. Okay. So, the states of the NFA, we will just say Q0, Q1, Q2, whatever. Coming to the states of the new DFA, we represent that by some bracket. Here I am going to use a brace. We can use square bracket as well. That doesn't make any difference. But just to differentiate from this Q2 to the Q2 of DFA, we are just going to use the brackets. Okay. Now, to start with, as I told, Q0 is the start state of the NFA. That will become the start state of the new DFA. So, we are going to write Q0 within brackets. This set will have only one entry, which is Q0. Now, for state Q0, what are the two inputs? 0 and 1. We will apply the inputs one by one. First, we will apply the input 0. So, input symbol equal to 0. Now, delta D of Q0 on 0 is same as delta N of Q0 on 0. So, what is Q0 on 0? Q0 on 0 is Q0 Q1. So, Q0 on 0 is Q0 Q1. Similarly, for input symbol 1, delta D of Q0 on 1 equal to delta N of Q0 on 1. What is Q0 on 1? Q0 on 1 is Q1. So, Q0 on 1 is Q1. Now, these two states we got, they are not in QD. Since these two states are not in QD, add them to QD. Now, QD will be equal to the set with Q0, then the set Q0 comma Q1, then the set Q1. Okay. So, for this Q0, we have already applied the transitions. Now, we will consider this Q0 comma Q1. Okay. So, now consider the state Q0 Q1. What are the inputs? 0 and 1. We will apply the inputs one by one. So, input symbol equal to 0. Delta D of Q0 comma Q1 on 0 is same as delta N of Q0 comma Q1 on 0. Now, we will split this into two separate transition functions. So, this is equal to delta N of Q0 on 0 union delta N of Q1 on 0. This step, delta N of Q0 on 0 union delta N of Q1 on 0. What is Q0 on 0? Again, we have to go see the transition table. Q0 on 0 is Q0 Q1. Similarly, Q1 on 0 is Q2. So, Q0 Q1 union of Q2 would be Q0 Q1 Q2. This is for input symbol 0. Now, the same thing, that is delta D of Q0 Q1 on 1. We are going to apply the input symbol 1 now. This is equal to delta N of Q0 Q1 on 1. So, again we will take the union. We will split it into two separate functions. Delta N of Q0 on 1 union delta N of Q1 on 1. By looking at the transition table, Q0 delta N of Q0 on 1 is Q1, delta N of Q1 on 1 is Q2. So, Q1 union Q2 would be Q1 Q2. Which are the two states we got now? Q0, Q1, Q2 and Q1, Q2. We will check if it is already in QD. If it is not in QD, we will add them to QD. So, QD would be equal to Q0, Q0 comma Q1, Q1, Q0 comma Q1 comma Q2, Q1 comma Q2. So, now we have already considered Q0, Q0, Q1. So, next state is Q1. So, consider the state Q1. Okay. For state Q1, apply the input 0. So, input equal to 0. Delta D of Q1 on 0 equal to delta N of Q1 on 0. Q1 on 0 is Q2 from the transition table. Now, apply the input 1. Okay. Delta D of Q1 on 1. Q1 on 1. See, Q1 on 1 is Q2. So, Q1 on 1 is Q2. Now, check for state Q2, whether it is already in QD. If it is already in QD, fine. If not, we have to add it to QD. So, QD will be equal to Q0, Q0 Q1, Q1, Q0 Q1 Q2, Q1 Q2 Q2. So, now we are done with this. This is done. This is done. We will have to consider Q0 Q1 Q2. So, consider the state Q0 Q1 Q2. So, we will have to apply the inputs 0 and 1. Let's first apply input 0. So, input equal to 0. Delta D of Q0 comma Q1 comma Q2 on 0 is same as delta N of Q0 comma Q1 comma Q2 on 0. So, we are going to split this transition function. This is equal to delta N of Q0 on 0 union delta N of Q1 on 0 union delta N of Q2 on 0. So, what is Q0 on 0? Q0 on 0 is Q0 on 0 is Q0 Q1. So, Q0 on 0 is Q0 Q1. What is Q1 on 0? Q1 on 0 is Q2. So, Q1 on 0 is Q2. What is Q2 on 0? Q2 on 0 is 5. So, Q2 on 0 is 5. Q0 Q1 union Q2 would be Q0 Q1 Q2. 5 we leave because whenever you take the union of 5, that won't be considered. That is Q0 comma Q1 union Q2 union 5 would be Q0 Q1 Q2. Now, apply the input 1. Delta D of Q0 comma Q1 comma Q2 on 1 equal to delta N of Q0 comma Q1 comma Q2 on 1. Again, we will split this transition function. This is equal to delta N of Q0 on 1 union delta N of Q1 on 1 union delta N of Q2 on 1. So, Q0 on 1, look at the transition table. Q0 on 1 is Q1. So, Q0 on 1 is Q1. Q1 on 1, Q1 on 1, Q1 on 1, Q2. So, Q1 on 1 is Q2. Q2 on 1, Q2 on 1 is Q2. So, Q2 on 1 is Q2. Now, take the union of Q1 union Q2 union Q2. So, that would be Q1 comma Q2. Now we will have to consider the state Q1, Q2. So for state Q1 comma Q2, input equal to 0. We will have to apply both the inputs 0 and 1. So delta D of Q1 comma Q2 on 0 is equal to delta N of Q1 comma Q2 on 0. This is delta N of Q1 on 0 union delta N of Q2 on 0. So Q1 on 0 is Q2, Q2 on 0 is 5. Q2 union 5 would be Q2. Now we will have to apply the input 1. The same process, delta D of Q1 comma Q2 on 1 equal to delta N of Q1 comma Q2 on 1. Split this transition function. This is equal to delta N of Q1 on 1 union delta N of Q2 on 1. Q1 on 1, the table. Q1 on 1 is Q2, Q2 on 1 would be Q2. So Q1 on 1 is Q2, Q2 on 1 is Q2, Q2 union Q2 is Q2. Okay. Now consider the state Q2. Consider the state Q2. Input equal to 0. Delta D of Q2 on 0 equal to delta N of Q2 on 0. So what is Q2 on 0? Q2 on 0 is 5. This is 5. Apply the input 1. Delta D of Q2 on 1 equal to delta N of Q2 on 1, which is Q2. Okay. So there are Q2 is already in QD. So no new states get added to QD. We stop at this stage. Now with all the transitions whatever we have found, we prepare the transition table. Okay. So Q0 on 0 is Q0 Q1, Q0 on 1 is Q1. Q0 Q1 on 0 is Q0 Q1 Q2, Q0 Q1 on 1 is Q1 Q2, Q1 on 0 is Q2, Q1 on 1 is Q2, Q0 Q1 Q2 on 0 is Q0 Q1 Q2, this on 1 is Q1 Q2, Q1 Q2 on 0 Q2, this on 1 is Q2. Q2 on 0 is 5, Q2 on 1 is Q2. Okay. And we know the start state is Q0. Coming to the final state, Q1 is the final state of the given NFA. So wherever we have Q1, all those states we make it as a final state of the new DFA. So there is Q1 here, make it as the final state. 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 Here, no. So 1, 2, 3, 4, 5, 6. There are 6 states in the new DFA. So let us do the diagram. Okay. So this would be the diagram. Q0, Q0, Q1, Q1, Q0, Q1, Q2, Q1, Q2, Q2. So write all the states first, then make the final states. So yeah, Q1 also is the final state. This is also the final state. Okay. Okay. So let me explain the transition diagram. We will write all the states. The 6 states are written here. Q0 on 0 goes to Q0 Q1. Q0 on 0 goes to Q0 Q1. Q0 on 1 goes to Q1. Q0 on 1 goes to Q1. Q0 Q1 on 0 goes to Q0 Q1 Q2. Q0 Q1 on 1 goes to Q1 Q2. So Q0 Q1, this one, Q0 Q1 on 1 goes to Q1 Q2. 1 goes to Q1, Q2. Q1 on 0 goes to Q2. Q1 on 0 goes to Q2. Q1 on 1 goes to Q2. So, Q1 on 1 also goes to Q2. Q0, Q1, Q2 on 0 is a loop. Then Q0, Q1, Q2 on 1 goes to Q1, Q2. On 1 goes to Q1, Q2. Now, Q1, Q2 on 0 goes to Q2. On 1 also it goes to Q2. Q2 on 0, no transition. Q2 on 1 is a loop. So, it goes to 1. So, this is about conversion of NFA to DFA using lazy evaluation method. Thank you.